Hello, welcome to this video. In the previous video leading up to this one, which was part 1, we introduced contingency tables. We created a 2x2 contingency table in SPSS, and then we proceeded to use that table to answer basic probability questions. And then you had the opportunity to review the addition rule, the multiplication rule, and conditional probability. So in this video, we'll follow along the same theme. We'll first of all start by reviewing hypothesis testing, and then in the following video, which is part 2b, we will conduct a chi-square test for independence or a chi-square test for association. We will do that first by hand, and then we will do it using SPSS. Okay, so let us start with hypothesis testing, and we are first of all going to go through a few steps that are important when you conduct hypothesis testing. The first step is to state your hypothesis, right? Remember that you have to state your hypothesis. One of the hypotheses is the null. The other one is called the alternative hypothesis. Okay, so number 1, we state our hypothesis. So we state the hypothesis. Okay, there are 2 of them. We have the null hypothesis, which is H naught, right? H naught, which is the null hypothesis. And then we have H sub 1, which is the alternative hypothesis. The null hypothesis is called the hypothesis of no difference, right? So this is the hypothesis of no difference. And the reason why it's called the hypothesis of no difference is because it proposes, right? The null hypothesis proposes that nothing new is happening, that in our research, nothing special is happening, right? On the other hand, the alternative would say there is something new happening. So we call it the hypothesis of difference, right? The other name for the alternative hypothesis is that it is the research hypothesis. So it's what the researcher is interested in proving or in determining, but to do that they follow a process that is impartial, in that they have to assume that their guess is wrong basically. So they give the benefit of the doubt to the no difference hypothesis, that what they propose is not happening in the sample. And so what then we do with the hypothesis testing is that we put the null hypothesis on trial, as it were. If the null hypothesis passes the hypothesis testing process, we stick with the null hypothesis. If, however, the null hypothesis then fails, then we will take our alternative, the research hypothesis. Okay, so the other thing to note is that these statements, the null hypothesis and the alternative hypothesis, these are statements about a parameter. So they are statements about the population, statements about a parameter, a certain measurement that tries to describe the population. They are not statements about our sample. This is important, right? So they are statements about a parameter found in the population. So that parameter can be mean, that parameter can be a certain proportion that we are interested in, or that parameter can also be, in certain instances, it can be the variance or the standard deviation, right? So that parameter can also be a standard deviation. Okay, so there are statements about the population. That's the take home there. And then step number 2, after we define our hypothesis, then we move on to step number 2, which is that we define or we choose the level of significance, right? So the level of significance. So this is the level at which we would reject or fail to reject the null hypothesis, right? And we call that the alpha level, and it's usually set to alpha is equals to 0.05, right? So this is an arbitrary number. Sometimes we may choose a number like 0.01 or even 0.001, depending on the sample size. Especially if the sample size is so large, you may find that it's better to conduct your test at 0.001. But for most scientific research, the significance level is set to 0.05. What this means is the alpha level, it's 5%, right? So this 0.05 is actually 5%. It gives us the probability of rejecting the null hypothesis, given that the null hypothesis is in fact true. Okay, so it's what is called a type 1 error. So basically the alpha level is the probability of a type 1 error, what we call a type 1 error. And a type 1 error is the probability of rejecting the null hypothesis, right? The null hypothesis is the one on trial. The probability that we will reject the null hypothesis wrongly, reject it given that the null hypothesis is in fact true. Okay, so we call that the alpha level. After we choose our significance level, then we move to step 3. Okay, step 3. In step 3, we calculate the sample statistic. So we calculate the sample statistics. And the sample statistics come from our sample. So these are numbers that we get from the sample that we have collected from the population. They are basically the sample size, which is n. N is the sample size. We have x bar, s. We also have, if you are working with proportion, we'd have the sample proportion. So x bar is the sample mean, okay, sample mean, and then s is the sample standard deviation. And then if you are concerned with the proportion, estimating a certain proportion, then we calculate the sample proportion. Sample proportion. Okay, so these are our sample statistics. Right, so in step number 4, okay, step number 4, we then use the sample statistics that we calculated in step 3 to find what is known as the test statistic. So we use our sample statistics to calculate the test statistic. So the test statistic is calculated in different ways depending on what we are testing. If we are conducting, let's say, a chi-square test, like we will do in the following video, the formula for chi-square test, right, that gives you the test statistic, right? The test statistic is actually the chi-square value, right? It's just a number. The number may come as, let's say, 2.15. So it's just a number. You get that number by using a formula. So the formula for getting the chi-square value, which is a test statistic, is given by the following formula: the sum of observed frequencies minus expected frequencies squared divided by the expected frequencies. Okay, so what this means is for every cell in our two-way contingency table or in our contingency table, for every cell, we look at the observed frequency in that cell, and then we subtract something called the expected frequency. And then I'll show you how we get the expected frequency in the next video. But what the expected frequency is basically another table that is created with the assumption that the null hypothesis is true, right? We create that table with the assumption that there is no relationship or no association between the two variables that we are testing. Okay, if we create that table, we get expected values, right? And then we take those expected values, we minus them from the observed value in a cell, we square that, we divide that by the expected value, and then we sum all those cells, right? And then after we sum them, that number, that result is the chi-square value, and that is what we call a test statistic. Okay, now step number 5. So in step number 5, we use the test statistic that we found in step 4 to find the p-value. So we find p-value. Okay, we find the p-value for the test statistic. For the test statistic. Okay, so there are two ways to do it. We can find the p-value by using a statistical like program or software like SPSS. If we are doing it by hand, then you need some tables. So you need a table that lists probabilities. Okay, so there are many different types of tables, again depending on the type of test. If you are doing a chi-square test of independence, then you are going to use what we call a chi-square. So you are going to need the chi-square distribution table. Let's suppose you are doing a test, you are testing mean, you would need the t distribution, right? So you may use the t distribution table. If you are testing, let's say, proportion, then you would use the z distribution or the standard normal distribution table. So the z distribution table. Okay, so there are many other tables that you can choose from, right? But these are the most popular ones that you come across, especially in an introductory statistics course, right? So the chi-square distribution, t distribution, and the z distribution table. Okay, so now let us move to step number 6. So in step number 6, what we do is, so step 6, so we make a decision based on the p-value. Okay, so based on the p-value that we calculated in step number 5, we make a decision, and we can go two ways. One, we can reject. Remember, the null hypothesis is the one on trial, so we can reject the null, right? Or we can fail to reject, right? We don't accept the null hypothesis, we fail to reject, right? Meaning that there is no evidence, we can't really accept, but what we are saying is there is no evidence to reject it, so we have failed to reject it by our sample. Okay, so we fail to reject the null hypothesis. In what conditions do we reject or fail to reject? So if the p-value is less than 0.05, then we reject the null hypothesis. That constitutes a significant finding. We call this statistically significant. A p-value of less than 0.01, or rather a p-value of less than 0.05 is referred to as statistically significant. And then we fail to reject if the p-value is greater than 0.05. Right, so that's basically that. And then we move to step number 7. Right, so having made your decision in step number 5 to reject or fail to reject, you then make your conclusion, or you state your conclusion based on the preceding step, based on step number 6. So if, let's suppose that you are testing for association, so the null hypothesis would say there is no association between two variables. Like maybe there is no association between gender and smoking, or gender and alcohol use. Okay, so the null hypothesis would say no association. The alternative would say, the research hypothesis would say there is an association, right? Maybe that gender can be used to predict whether someone drinks alcohol or not. Okay, so if we run through the hypothesis test and then we get a p-value that is less than 0.05, we would then reject the null hypothesis. So we would state our conclusion as there is evidence, or there is enough evidence, right, to, let's say, demonstrate demonstrate an association between our variables, right? Whatever those variables are, between variables A and B. Okay, so that's how we would state our conclusion. Right, so in the next video, which is part 2b, we will now follow the same steps but with an actual example, an actual problem of a chi-square test, where we'll be testing for independence between two variables, and in that case the variables are going to be gender and exercise, and to see whether there is an association between those two variables.